Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. My name is Faris bin Muhafiz. Today our group from Group 12 will be present on design for refrigerated container for subject heat transfer SEMM3033 section 22 by lecturer Dr. Amin Saad. I hope you guys enjoy. Before we start, I would like to introduce to our group member. Basically, Group 12 consists of three gentlemen. From left, Mr. Amir Shadi bin Muhammad Azman, Ahmed Arif bin Yusuf, and last is myself, Faris bin Muhafiz. For introduction, refrigerated containers, often known as reefer containers, are used to convey commodities that require temperature control. Reefer containers are outfitted with a refrigeration unit that is wired to the ship's power source. They are intended to keep the container's temperature, humidity, and environment constant during the duration of the journey. When transporting refrigerated cargo, four factors must be considered: temperature, ventilation, humidity, and drainage. Okay, for the first point, temperature. For chilled and frozen goods, all standard reefer containers are designed to sustain a temperature between positive 25 and negative 25 degrees Celsius. A portion of the worldwide reefer fleet is also capable of holding temperature as low as negative 35 degrees Celsius. For the next factor, which is ventilation, at all times, air must circulate through the cargo to remove heat and gases in order to maintain a cool temperature. Therefore, the shipping containers must have ventilation. And the next point is humidity. Some items benefit from a decrease in humidity levels. A reefer unit's dehumidification function can reduce the air's relative humidity. Although some modern units can reach 50% relative humidity, the norm is between 60 and 85%. And the last is drainage. They are used to prevent the accumulation of excess water within containers. Moreover, their design prevents water and insects from entering the container. For our design description, this remarkable innovation has had a significant impact on the export and import industry and has made significant contribution to the food industry. So in this project, our team has been tasked with designing a refrigerated container truck capable of transporting 350 kilometers of frozen food from a warehouse to a hypermarket. This distance results in around 5 hours of driving time. The container must have overall dimensions of 5.5 meters in length, 2.3 meters in width, and 2.5 meters in height. Another criterion is that the refrigerant must be dry ice. Dry ice, dry ice costs 6 ringgit 50 cent per kilogram at the moment. So, by utilizing heat transfer applications and knowledge, we are required to come up with the most efficient design to prevent food from melting and spoiling during transit. So, the problem statement for this project are: assuming the design capability, we must estimate the size of the dry ice compartment that can resist and maintain a temperature of negative 5 degrees Celsius while the container's exterior surface temperature at 40 degrees Celsius during the journey. Next, the thickness of the container and type of insulator to be used to achieve the specification and the optimal design of the container's walls and floor. The last is the most effective, cost, and efficient application of dry ice is the one that provides the most acceptable and fair amount of the substance.
Container design. So our group decided to use stainless steel as the outer and inner surface of the container. So for the outer surface, stainless steel is selected because it is known for its resistance to water. Second, it's sufficiently reactive to protect itself from future assault by generating a passive corrosion product layer. And for the inner surface, it does not leach chemical and does not absorb bacteria. Therefore, it is suitable for food storage. For the insulation, we use polyurethane, and it is one of the best performing insulation material. It is commonly used in construction. Second, we use closed cell spray polyurethane foam, where it is the most popular type of insulation being used for shipping container. Next is the placement of dry ice container. We decided to place the dry ice container under the roof of container. So why do we do this? It is because of the air circulation inside the container. Hot air has lower density compared to cold air. Therefore, the hot air inside the container will be cooled by the dry ice as it moves upward. And when the hot air become cool, it will become more dense and the air will move downward and it will cool the frozen food that we carried inside the container.
These are the assumptions we are applying while calculating the heat transfer caused by composite wall. First, temperature outside maintained at 40 degrees Celsius throughout the trip. Neglect heat release by the product. Neglect radiation caused by the road. Dry ice maintain its optimal temperature until placed inside the container. Air is an ideal gas. Thermal properties are constant. And we neglect heat transfer caused by truck moving at different speed. To calculate the amount of dry ice needed for a 5-hour trip, we need to know the total heat transfer rate caused by the thermal resistance. First, we calculate the heat transfer rate at container side wall. By calculating the resistance of two stainless steel and the insulation which are placed in between the two stainless steel, we can then calculate the heat transfer rate using the formula Q equals to delta T over R. We then repeat the step for the container's roof, floor, front wall, and door. We then calculate the amount of dry ice needed to maintain the temperature of the container. We can calculate the value of m dot by dividing the heat transfer rate by 591 kJ per kg, which is the specific latent heat of sublimation. We then change the unit of m dot from kilogram per second to kilogram per trip. And lastly, we can calculate the cost of dry ice by multiplying m dot with the price of dry ice per kg.
Discussion. Few assumptions were taken into consideration before we begin with the heat transfer analysis. For example, we don't consider the heat radiation from the road, and also we neglect the heat release by the food being carried inside the container. All material that are being chosen, stainless steel and polyurethane, are being selected meticulously to meet its purpose. As an example, we select stainless steel because of its durability towards water, which is rain, and for the inside layer, we also select stainless steel because it does not absorb bacteria, so it is safe for us to carry food inside it. As for polyurethane, it is known for its performance as an insulation. The container of dry ice is placed under the roof to cool the entire truck to the desired temperature, -5 degrees Celsius. And lastly, the container is being designed to fit 22.03 kg of dry ice for each trip, according to the analysis being made. Is dry ice sustainable to be used? These are the advantages. Dry ice is readily available. Second, it is suitable for transportation of goods that require the air to be dry. However, there's a few disadvantages, which is dry ice is only be in advantage for short-term use as the dry ice sublimate into carbon dioxide gas. Second, dry ice might be hazardous when released in a confined or unventilated area as it produces oxygen deficient atmosphere, which may be hazardous to the health. Using dry ice is dangerous to dispose as it requires special handling. And lastly, using dry ice is time consuming as the dry ice need to be refilled for each trip.
From the design, we can assume that the insulating material can affect the price of dry ice, which will ultimately have a financial impact on the company. If the insulation is thicker than the optimal working thickness for each material, heat transmission will be minimized and the cooling compartment's temperature will be maintained. The aforementioned heat transfer study demonstrates that the highest cost for the journey is RM143.20. The trip's maximum cost is fairly significant because the analysis is based on the optimal thickness for each material to function optimally. The highest quantity of heat that may be transported through the material is likewise observed to be 0.7231 kilowatt. This number can be decreased if the trip utilizes a thickness greater than the optimal thickness specified. The insulating material is readily available and accessible on the market. To lower the cost of the trip, it is necessary to have a greater thickness than the optimal thickness for each material.